Great. So let's keep going. For what do we do? So how do we develop? This book, fourth chapter would talk about the steps for TinyML development. Essentially, on the second chapter, we talk about understanding TinyML, need, benefits, list of TinyML verticals, and such. And so what do we do when we talk about developing a TinyML application? Essentially, these boards, they have sensors. What sensor means in this context is your camera has image sensor, your audio, microphone is audio sensor, gyroscope, accelerometer, these are movement sensors, and you might have magnetometer, which is your magnetic sensor, and there are other kind of sensor which can sense flow, your location and such, right? And there are over 1,000 sensors for different kinds. But the whole idea of the sensor is that you connect that sensor to a board, and sensor is taking the data into some other form and converting it to a digital form. So, for example, image, right? All these sceneries that we see are converted into pixels. Pixel is nothing but an 8-bit or 16-bit representation of a very tiny dot that creates the whole picture. And same thing with your microphone. Microphone senses a sound waveform. The speaker will convert that sound to a power waveform that you can analyze in terms of the frequency band and its characteristics, and spot the variation and spot the pattern into identifying whether it's your voice, my voice, dog barking, glass shattering, or something else. So gather data is the first step. Then you design the network. Network meaning neural network. And then you train the model. So the model is trained, and the model says my accuracy is 90%, 95%, 98%. And the more the complexity of the data that comes from the sensor requires high-end, high-compute models that needs to be trained with high accuracy depending on the criticality of the application. And once the model is trained, then you validate. Validate as in you have collected the data from, let's say, for camera from January through March, and you would like to validate that on the pictures that were captured in July, because the model now has never seen the pictures that are captured in July timeframe. Why do I bring up these months into this picture? Is because essentially the model sees the data that it has never seen before during training. So you're validating, does it do a similar does it bring out the similar accuracy on the data that it has not seen before? So that's a model validation, and then you compile the model. Compilation is one differentiation which is very specific to embedded systems and TinyML boards. These boards cannot have operating system, meaning you have to compile the model. They can't run Python. Python is where the whole industry is tuned to training the model. It's very easy to train a model using Python and the Python-related frameworks like TensorFlow and PyTorch and MX and Caffe, and there are a lot more. So the language that is used here is Python, but then because these boards are so tiny that the memory and the flash, which is the hard disk, is less than 1 megabyte. Now compare that to your cell phone, which is about 64 gigabytes of hard disk. 1 megabyte versus 64 gigabytes is about 10 to the power 4 to 10 to the power 5 difference in just storage. So it's a huge order, 4 to 5 orders of magnitude difference between the board that we are talking here and your cell phone, which is probably a basic device for you. Wasn't so back in 1970s or 80s. Just so you know, give you another example, the cell phone that you have in your pocket today was used to send a man to the moon. The kind of compute you carry in your pocket today, that compute wasn't available back in 70s, 60s to 70s. And the scientists they used very large computers, which if you compare, the compute power is similar to what you carry around in your pocket. So we've come a long way in terms of compute, but still we would like to bring the TinyML devices into the basic compute, essentially the microcontrollers and boards of 19.